In this video, we're going to talk about a GitOps tool that is gaining popularity in the DevOps world, which is called ArgoCD. If you don't know what GitOps is, you can check out my other video about GitOps, after which this video will make much more sense to you. First, I'm going to explain what ArgoCD is and what are the common use cases or why we need ArgoCD. We will then see how ArgoCD actually works and how it does its job. And in the final part, we will do a hands-on demo project where we deploy ArgoCD and set up a fully automated CD pipeline for Kubernetes configuration changes to get some practical experience with ArgoCD right away. ArgoCD is, as the name already tells you, a continuous delivery tool. And to understand ArgoCD as a CD tool or continuous delivery tool, let's first understand how continuous delivery is implemented in most projects using common tools like Jenkins or GitLab CI CD, and then see how ArgoCD compares to them. And in that context, we will answer the questions such as, is ArgoCD just another CD tool? Or what is so special about it? And if it's so special, does it actually replace any of these other established tools like Jenkins or GitLab CI CD? So let's say we have a microservices application and we're running it in a Kubernetes cluster. When things change in the application code, like new feature or a bug fix gets added, the CI pipeline on Jenkins, for example, will be automatically triggered and will test the changes, build a new Docker image, and push it to a Docker repository. Now, how does this new image get deployed to Kubernetes? We update application's deployment YAML file for Kubernetes with the new image tag, and this YAML file then should be applied in Kubernetes. In most projects, these steps are the continuation of the CI pipeline. So after the image gets pushed to the repository, Jenkins will update the deployment YAML file for the application, and using kubectl tool, for example, will apply the updated deployment file to Kubernetes. And this is how many projects are set up. However, there are a couple of challenges with this approach. First of all, you need to install and set up tools like kubectl or Helm, etc., to access Kubernetes cluster and execute changes on those build automation tools, right? So you would need to install and configure them on Jenkins. You also need to configure access to Kubernetes for these tools because kubectl is just the Kubernetes client, and in order for it to connect to Kubernetes, it needs to provide some credentials. So you would need to configure credentials for Kubernetes cluster in Jenkins. If you're using K8s cluster, which is a Kubernetes managed cluster on AWS, for example, in addition, you would also need access to AWS. So you'd have to add AWS credentials in addition to the Kubernetes credentials also to Jenkins. And this is not only a configuration effort, but also a security challenge because you need to give your cluster credentials to external services and tools. Especially if you have 50 projects that deploy applications to the cluster, each project application will need its own Kubernetes credentials so that it can only access that specific application resources in the cluster. Same way, if we have 50 clusters where things get deployed, we would have to configure it for each and every cluster. And the third challenge, and probably the most important one, is that once Jenkins deploys the application to Kubernetes, or it applies any changes to Kubernetes configuration, it has no further visibility in the deployment status. So once kubectl apply was executed, Jenkins doesn't actually know the status of that execution. Did the application actually get created? Is it in a healthy status? Or is it actually failing to start? And so on. You can only find that out with following test steps. So the CD part of the pipeline, when working with Kubernetes specifically, can be improved and made more efficient. And ArgoCD was built for this specific use case to make continuous delivery to Kubernetes clusters specifically more efficient. ArgoCD was actually purpose-built for Kubernetes with GitOps principles, and we will see why this is a good thing throughout this video. So how does ArgoCD make the CD process more efficient and address the challenges with the common CD flow that I mentioned? We basically just reverse the flow. Instead of externally accessing cluster from the CI/CD tool, like Jenkins, the tool is itself part of the cluster. And instead of pushing the changes to the cluster, we use a pull workflow where an agent in the cluster, which is ArgoCD, pulls those changes and applies them there. So now let's see how does the workflow look like when we replace the common CD setup with ArgoCD. First, we deploy ArgoCD in the cluster, and then we configure ArgoCD and tell it, hey, connect to this Git repository and start watching for any changes. And if something changes there, automatically pull those changes and apply in the cluster. So now when developers commit the application changes to the application source code repository, a CI pipeline on Jenkins, since we're using Jenkins as an example, will automatically start a build process. It will test the changes, build the image, push it to the repository, and finally update Kubernetes manifest file, like deployment.yaml, with a new image version. Now, a very important note here about repositories is that it has been established as a best practice to have separate repositories for application source code and application configuration code. So Kubernetes manifest files for the application would be hosted in its own Git repository. And one of the main reasons for that is because the application configuration code is not only the deployment file, but it could be config map, secret, service, ingress, and so on, and basically everything that the application may need to run in the cluster. And these files can all change completely independent of the source code, right? And when you update a service YAML file for the application, which is just the application configuration and not part of the code, you don't want to run the whole CI pipeline for the application because the code itself has not changed. And you also don't want to have a complex logic in your build pipeline that has to decide and check what actually changed. So again, the Jenkins CI pipeline will update the deployment.yaml file in a separate Git repository where the Kubernetes manifest files are for the application. And as soon as the configuration file changes in the Git repository, ArgoCD in the cluster will immediately know about it because we configured it at the beginning to constantly monitor the repository for changes. And it will pull and apply those changes in the cluster automatically. ArgoCD supports Kubernetes manifests defined as plain YAML files, Helm charts, customized files, or other template files, which eventually all get generated into plain Kubernetes YAML files. So you can use all of these with ArgoCD. And the repository for configuration files, which is tracked and synced by ArgoCD, which is a GitOps tool, is sometimes also called a GitOps repository. So now, whether the application configuration repository gets updated by Jenkins in case of an image version update in the deployment YAML file, or by DevOps engineers where they change other manifest files, the changes will get automatically pulled and applied in the cluster by ArgoCD. And as a result, we end up having separate CI and CD pipelines, where the CI pipeline is owned mostly by developers and configured on Jenkins, for example, and CD pipeline is owned by operations or DevOps teams and configured using ArgoCD. In this way, we can still have an automated CI/CD pipeline, but with a separation of concerns, where different teams are responsible for different parts of that full pipeline. Now let's see some benefits that using GitOps in your project has with an example of ArgoCD. The first benefit is that we have the whole Kubernetes configuration defined as code in a Git repository. So instead of everyone doing stuff from their laptops and executing scripts and doing kubectl apply or helm install commands, they all use the same interface to make any changes in the cluster. And that could be the first big benefit of using this model. Now, a very interesting use case arises here when someone in the team decides, you know what, let me just quickly update something in the cluster. It's much quicker to just do a kubectl apply than to write the code changes, commit that, push that, and get a review from colleagues, and then eventually merge it in the repository. So now what happens when people update the cluster manually in addition to having the configuration code defined in the Git repository? Well, ArgoCD does not only watch the changes in the Git repository, but it also watches the changes in the cluster. And anytime a change happens either in the Git repository or the cluster, it compares those two states. And if it sees that something has changed in any of the two places and they don't match anymore, so the desired state defined in the Git repository does not match the actual live state in the cluster, it knows that it has to do something. And that something is always to sync whatever is defined in the Git repository to the cluster. So in that case, if someone goes and makes manual changes in the cluster, ArgoCD will detect that and it will see that the states have diverged. So the cluster state is different than the Git repository state, and it will sync the changes and basically overwrite whatever was done manually. And this is really useful because this actually guarantees that Git repository and whatever is defined there remains at any time the only source of truth for your cluster state. And it also gives you a full transparency of the cluster because you know that whatever is defined in that Git repository as a configuration code is exactly the state which you have in the cluster. Now, it could be that many projects need time to adjust to these workflows, and sometimes team members or engineers absolutely need a quick way to update things in the cluster before changing that in the code. And you can actually configure ArgoCD to not automatically override and undo those manual cluster changes, but instead send out an alert that something has changed in the cluster manually and that it needs to be updated in the code as well. So you have that option to configure ArgoCD in this way. And finally, as a result of using Git as a single interface for making changes in the cluster instead of untrackable kubectl apply commands, we have each change documented in a version controlled way, which gives us history of changes as well as an audit trail of who changed what in the cluster. But also, this gives teams a way to collaborate on any changes in the cluster, like proposing a change in Kubernetes, which others can discuss and work on, and when done, just merge those changes in the main branch. Another benefit of using Git for config files is an easy rollback. ArgoCD pulls any changes and applies them in the cluster. If something breaks with these changes, or let's say a new application version fails to start, we can revert to the previous working state in the Git history. Basically just by moving back to the last working version. Especially if we have thousands of clusters that all get updated by the same Git repository, this is going to be very efficient because you don't have to manually revert each and every component doing kubectl delete or helm uninstall and basically clean up all the things. You simply declare the previous working state and cluster will be synced to that state again. Another advantage is cluster disaster recovery, which becomes super easy with this setup. So if I have an EKS cluster in a region 1A and that cluster completely crashes, I can create a new cluster, point it to the Git repository where the complete cluster configuration is defined, and it will recreate the same exact state as the previous one without any intervention from our side. Because again, I have described my whole cluster in code in a declarative way. And I want to mention here that these are all actually GitOps principles and benefits that you get when implementing these principles. using whatever GitOps tool you want. So these are not specific benefits of ArgoCD itself, but ArgoCD just helps implement those principles. However, there are some benefits that using ArgoCD specifically has. Now, of course, you don't want every team member to be able to make changes to cluster, especially in a production environment. So again, using Git, you can actually configure access rules easily. You can say every member of the DevOps team or operations team, even junior engineers, can initiate or propose any change to the cluster and make pull requests. And only a handful of senior engineers can then approve and merge those requests. And this gives you a clean way of managing cluster permissions indirectly through Git without having to create cluster roles and users for each team member with different access permissions. So basically we have a benefit of easy cluster access management. And because of the pull model, you only need to give engineers access to the Git repository and not cluster directly. Now, in addition to human user access, with this workflow, we also have a benefit of easier cluster access management for non-human users, like CI/CD tools, such as Jenkins. So in this case, you don't need to give external cluster access to Jenkins or other external tools because ArgoCD is already running in the cluster and is the only one that actually applies those changes. So basically, cluster credentials don't have to be outside the cluster anymore because the agent runs inside the cluster. And this makes managing security in all your Kubernetes clusters way easier. As I mentioned, an advantage of using ArgoCD is that it's deployed directly in the Kubernetes cluster. But it's not just deployed in the cluster because you can actually deploy Jenkins in the cluster too. But it's really an extension to the Kubernetes API. So ArgoCD actually leverages the Kubernetes resources itself, and instead of building all the functionality itself, it uses some of the existing Kubernetes functionalities for doing its job, like using etcd for storing the data and using Kubernetes controllers for monitoring and comparing this actual and desired state. And what is the benefit of that? The main benefit is the visibility in the cluster that Jenkins, for example, does not have. That allows ArgoCD to give us real-time updates of the application state. So ArgoCD can monitor deployment state after the application was deployed or after the changes in the cluster configuration have been made. So for example, when you deploy a new application version, you can actually see in real time in ArgoCD UI that configuration files were applied, pods were created, application is running and in a healthy status, or if it's in a failing status and a rollback is needed. So if we zoom out and look at a big picture, we have Git repository on one side and Kubernetes cluster on another, and ArgoCD in the middle of these two. And Git is the desired state of our cluster at any time, and Kubernetes cluster is the actual state. And ArgoCD is an agent in the middle that makes sure these two are always in sync, updating the actual state with the desired state as soon as they diverge. Now, how do we actually configure ArgoCD to do all this? Basically, we deploy ArgoCD in Kubernetes, just like we deploy Prometheus, Istio, or any other tool. And since it was purpose-built for Kubernetes, it extends Kubernetes API with CRDs, or custom resource definitions, which allows configuring ArgoCD using Kubernetes native YAML files. And the main component of ArgoCD is an application. And we can define this application CRD in a Kubernetes native YAML file. And it looks like this. And the main part of the configuration of application is we define which Git repository should be synced with which Kubernetes cluster. And this could be any Git repository in any Kubernetes cluster. In terms of Kubernetes cluster, this could be the cluster where ArgoCD itself is running in, but it could also be an external cluster that ArgoCD manages. And you can configure multiple such applications for different microservices, for example, for your cluster. And if some applications belong together, you can group them in another CRD called app project. Now there is one more thing we need to address, which is working with multiple clusters and how we apply these processes in a multi-cluster environment. Let's say we have 3 cluster replicas for a dev environment in 3 different regions. And in one of the clusters, we have ArgoCD running and configured to deploy any changes to all 3 cluster replicas at the same time. And the benefit here is that Kubernetes administrators will only have to basically configure and manage one ArgoCD instance, and the same instance will be able to configure a fleet of clusters, whether these are 3 clusters in 3 different regions or 1,000 cluster replicas distributed all over the world. Now, what about multiple cluster environments? Let's say we have development, staging, and production environments, and maybe each environment with their own cluster replicas. And in this case, in each environment, we may deploy and run own ArgoCD instance, but we still have one repository where the cluster configuration is defined. And we don't want to deploy the same configuration to all environments at once. Instead, if something changes, we need to test the changes first on each environment and then promote it to the next one, right? So the changes will be applied to the development environment, and only if these changes are successful, then they will be promoted on a staging environment, and so on. So how do we achieve that in this workflow? For that, we have 2 options. The first one is using multiple branches in our Git repository for each environment. So you would have development, staging, and production branches, which is probably not the best option, even though it is commonly used. Another and a better option would be to use overlays with Kustomize, where you have your own context for each environment. So with overlays, you can reuse the same base YAML files and then selectively change specific parts in them for different environments. So now the development CI pipeline can update the template in development overlay. The staging CI pipeline can update the template in the staging overlay, and so on. So using these options, you can actually also automate and streamline applying changes to different environments. Before moving on, I want to give a shout out to Keston, who made this video possible. Keston's K10 is the data management platform for Kubernetes. K10 basically takes off most of the load of doing backup and restore in Kubernetes from the cluster administrators. It has a very simple UI, so it's super easy to work with, and has an intelligent logic which does all the heavy lifting for you. And with my link, you can download K10 for free and get 10 nodes free forever to do your Kubernetes backups. So make sure to check out the link in the video description. And now let's continue. Now, seeing some of the benefits that GitOps workflow and ArgoCD tool specifically provides, many people may ask, does that mean ArgoCD will replace Jenkins or GitLab CI CD and such tools? Well, not really, because we still need the CI pipeline, right? We still need to configure pipelines to actually test and build application code changes. And ArgoCD, as the name also implies, is a replacement for CD pipeline, but specifically for Kubernetes. So for other platforms, you will still need a different tool. Also, ArgoCD is not the only GitOps CD tool for Kubernetes. There are many alternatives already out there, and as the trend emerges and becomes even more popular, probably some more alternatives will be created. And one of the most popular ones right now is Flux CD, which works with and implements the same GitOps principles. So now that you understand all the concepts around ArgoCD, and not only what it is, but also why we should care about using it, it's time to see ArgoCD in action. And for that, we're going to use a simple but realistic demo. In the demo part, we will set up a fully automated CD pipeline for Kubernetes configuration changes with ArgoCD. I have a Git repository with deployment and service YAML files, where the deployment file references my own application's image version 1.0. I have 3 image versions that I've already created for this app in my Docker public repository, which means you can also access them and use that in your demo. So here we can just imagine that some kind of CI pipeline ran and built these images, but it doesn't matter for us, we just have them available. And we also have an empty Minikube cluster, but again, this could be any Kubernetes cluster you want. So with this setup, we will first install ArgoCD in Kubernetes cluster, and then configure ArgoCD with an application CRD component, where we tell ArgoCD, hey, this is the Git repository, you need to start tracking and syncing with this Minikube cluster. And that's it. From then on, we basically don't have to do anything in Kubernetes directly. We're just gonna be updating config files in Git repository, and ArgoCD will pull and apply these changes automatically. So let's get started. And as I said, I have an empty Minikube cluster. There is nothing running or installed on it yet. Plus I have an application configuration repository where only the Kubernetes manifest files for that application are hosted. And inside that I have one dev folder basically, and I have my deployment and service.yaml files here. They're super simple examples of an internal service and a deployment like this with 2 replicas and an image that basically points to my own application image with version 1.0. And this is a public image that I'm hosting on a Docker Hub, which you can also push and use in your demo, which is this one right here. And inside that I have these 3 image tags. We're using 1.0 in our deployment, and we're gonna basically update it to one of the later versions. So that's the whole setup. And you're gonna find the links to all the repositories in the video description so you can use them as well. And of course, since this is only the configuration repository, there is also an application source code repository that I used to build this image, which is a separate Git repository. I will also link that in the video if you want to see exactly what's in the image. But the source code itself is not very relevant for us. We just want to see how the deployment in Kubernetes works. So the first step is we want ArgoCD deployed in our cluster. So let's go ahead and do that. And you can reference the Getting Started guide of ArgoCD for that. And installing ArgoCD in Kubernetes cluster is super easy. It's just a one-liner basically. And you can also find the instructions for getting started on their official documentation page. So we can also reference that in this video. So first of all, we're going to create a namespace, ArgoCD, and ArgoCD and all its components will be running in that specific namespace. So these are the 2 commands that we need. So switching back to my command line, first I'm going to create an ArgoCD namespace in my cluster, and then we're going to basically apply a YAML file that installs everything that ArgoCD needs. Now, as an alternative, you can first download this YAML file and basically see what's inside and maybe save it to know exactly what will be deployed here. I'm just going to apply directly. So all of these will be installed in an ArgoCD namespace. So let's execute. And there you go. You see that bunch of components have been created. And now if I do get pod in an ArgoCD namespace, I should see a bunch of pods being created. So we're going to wait for all the pods to get in a running state, and then we're going to access ArgoCD UI. Great, so the pods are all running. Now, how do we access the ArgoCD UI? If we check the services that were created, we have one of them, which is ArgoCD server, which is accessible on HTTP and HTTPS ports. So we're just gonna use kubectl port forward to access this service. Port forward, let's not forget the ArgoCD namespace. and we're going to port forward a service, ArgoCD server, and make it available locally on port 8080. So forward the service requests on this port to localhost port 8080. And let's execute like this. And now if I grab that URL, we're going to get a warning of the connection because it's HTTPS but not secure. We're going to proceed anyway, and here we're going to need to log in to ArgoCD UI. And again, going back to getting started guide, we can see how to log in to the service. First of all, the username is admin, and the password gets auto-generated and saved in a secret called ArgoCD initial admin secret. So if I get that secret in an ArgoCD namespace, and let's do YAML output. Here we have a password attribute with a base64 encoded value. So that's basically the password. We're gonna decode it, and there you go. So that's the password. You can ignore the percentage sign here and just copy the string and use it as a password. Paste it in, sign in, and there you go. And as you see, ArgoCD is currently empty. We have no applications because we first need to configure it. So right now it doesn't do anything. So that's going to be our next step. Let's write a configuration file for ArgoCD to connect it to the Git repository where the configuration files are hosted. And we're going to put that ArgoCD configuration file also in this configuration repository. So I have checked out the project, which you can also go ahead and do. So just clone it, and we're going to work on this project locally. So I'm going to switch to that project, and where we have this dev folder with the configuration files, and I'm going to open this whole thing in a Visual Studio Code, and there you go. So now let's create an ArgoCD configuration, and let's call it application.yaml. And the configuration is actually very simple. First of all, we have our already familiar fields from Kubernetes, which are API version. And for custom components or custom resource definitions, the API version is from the project itself. So this is going to be Argo project IO. And that's the version, which is still alpha. Then we have the kind, which is application. Metadata, where we have the name and the namespace. So let's call this my app Argo application. And the namespace will be ArgoCD. So this application component will be created in the same namespace where ArgoCD is running. And then we have the specification, which is specific to this application kind. Now, very important note about the API version. This, of course, changes. So as they move it from alpha to beta and then just basically release it, this will change. So when creating this application kind, please always refer the documentation to make sure you have the correct values here. And you can see the example in the documentation right here. In the application section, you have this example application definition. And I'm going to link this also in the description. So moving back to the specification, we have a couple of attributes. First of all, we have the project, which, as I said, you can group multiple applications into a project. If we don't care about that, we just use the default project. That's where everything goes by default, and leave it at that. And then we have two things that we want to configure in every application. The first one is the Git repository that ArgoCD will connect to and sync it. And the second one is the destination or the cluster where ArgoCD will apply the definitions it found in the Git repository. So the source of the configuration and the target or destination cluster for that configuration. So we have source for the Git repository, and for this we have repo URL, and that's going to be our Git repository. So just copy this URL right here. We also have target revision, and we're going to point it to head. So that's basically always the last commit in that Git repository. And we also have path attribute that lets us specify whether we want to sync or track a specific path in that repository. And since we have dev path, we're gonna use that one. So that's the configuration for repository as a source. And then we have destination. And that's gonna be the address of the Kubernetes cluster itself, which is the API server. And because we're running ArgoCD inside the destination cluster itself, we can put a DNS name here for Kubernetes API server, which is kubernetes.default.service. So that's basically an internal service name of Kubernetes API server. And if we check that, if we do kubectl get service in the default namespace, you see that we have this Kubernetes service, which basically is the internal service for API server. And because, again, ArgoCD is running inside the cluster, it can access the internal services directly. We don't have to provide an external cluster endpoint. But as I said, ArgoCD can also connect to clusters externally, or it can manage multiple clusters and synchronize the definitions to multiple clusters at once. And for that, you would then use an external address of your cluster. So that's going to be the server address. And finally, we can also specify a namespace. So basically, when ArgoCD finds those configuration files, in which namespace it should apply them. And if it's not default, then we would have to specify a namespace here. And let's say we want all this configuration to be created in a MyApp namespace. Now, we actually don't have a MyApp namespace currently in the cluster. So when ArgoCD tries to deploy this, we want ArgoCD to automatically create this namespace if it doesn't exist already in the cluster. And we need to configure that as well. And to configure that, we have another attribute called sync policy. And inside that, we have sync options. And one of the sync options or synchronize options is create namespace equals true. So by default, it's false. It's not going to create a namespace automatically if it doesn't find it, but we're going to set it to true using this configuration. Now, there are a couple more things we want to configure here. The first one is, as we said, we want ArgoCD to basically automatically sync any changes in the Git repository. By default, that is turned off. So if you change and push something to the Git repository, ArgoCD doesn't automatically fetch that, but we can enable it simply by using automated attribute. And inside that automated attribute, we have two more options. The first one is, as I mentioned, we can configure ArgoCD to undo or overwrite any manual changes to the cluster. So if I did kubectl apply manually in the cluster, ArgoCD will basically override it and sync it with the Git repository state instead. And we can enable it using a self-heal attribute set to true. And finally, if we rename a component, for example, or if we deleted the whole service.yaml file, we want ArgoCD to also delete that component or that old component in the cluster as well. And that's going to be an attribute called prune, and we're going to set it to true. Now note that the automated attribute will configure ArgoCD to pull the changes in Git repository in 3-minute intervals. So ArgoCD will not pull the changes as soon as they happen in the Git repository, but rather it will basically check every 3 minutes whether something has changed and then pull and apply those changes in the cluster. That's how it's going to work. Alternatively, if you absolutely needed to configure your workflow to always basically apply and synchronize with cluster, as soon as something changes in the Git repository, you can actually configure a webhook integration between Git repository and ArgoCD. So you have that option as well. But we're going to just go with the default where ArgoCD checks for any changes in the repository regularly. Now you'll probably be wondering, why are these things turned off by default? So why do I have to enable automatic sync or undoing the manual changes and deleting the applications when their configuration gets removed, and so on. And my assumption is that it's a protection mechanism, that something doesn't get accidentally deleted. So you have to actually explicitly enable it, or that you don't want automatic syncs in the cluster or self-healing because your team needs some time to transition to this workflow. And maybe that's why you have to explicitly enable them. But as you see, enabling them and configuring that is not very difficult. And with this configuration, we're gonna fully automate all these actions. And that's basically our application configuration for this specific repository and this specific path. And as you already see from this configuration, in the same cluster, you may have multiple such applications for different namespaces or different environments that you can create in ArgoCD. Now we need to actually apply this configuration to configure ArgoCD with this logic. So let's go ahead and do that using kubectl apply. So this is going to be ideally the only kubectl apply that I have to do in this project, because after that everything should be auto-synchronized. So first I'm going to add this to the repository, to the remote repository basically. Because again, ArgoCD will connect to the remote repository, so we want the ArgoCD configuration to also be available there. And if I refresh, I will see my application.yaml. Now, ArgoCD doesn't know anything about this repository or this configuration yet. For that, we need to apply this application.yaml in the cluster. So let's go ahead and do that. And as you see, application component was created. And now if we go back to ArgoCD UI, you see that we have my app Argo application. That's the name that we gave the application component. And it seems like it has successfully synced everything from this repository. Now we can click inside to see more details. Details about successful sync, but also a pretty cool feature in the UI is this overview here of different components that the My App Argo application triggered to create. So this is the ArgoCD application component itself. And this one actually triggered creation of the service, as you see with the service icon here. And you also see all the components that have been created in the background from these top level components. So we have the deployment here, we have the replica set behind that deployment, and we have the 2 pod replicas, because we have 2 replicas defined here of this specific image, as you see, in those pods. And again, you click on one of these components for even more details. So if I click in the pod, you see the main data, including the image, as well as the actual state manifest. You see the events for that pod, as well as the logs, which are some pretty neat additional features here. And the same way, you can also click into the application, and here you have the details of the application that we provided, like repository URL, create namespace, automatically enabled, the sync policy, prune, self-heal, and so on. And you can edit them here as well, and you also have the manifest view or the YAML view that we configured right here. Awesome. So now let's actually test the automatic sync by updating something in the configuration. So what we're going to do is go into the deployment.yaml file and update the image to a later tag. And I'm going to do it directly in the GitLab user interface, so we don't have to commit and push, etc. And let's change the tag to 1.2 and commit the changes. And now, at a certain interval, when ArgoCD checks the Git repository for any changes, it will see that the desired state has changed and it's 1.2 and not 1.0 that we have running in the cluster, and it will automatically sync those changes. And as you saw, ArgoCD showed the application state out of sync very briefly, and then the deployment got updated. So a new replica set was created in the background, which then started 2 pods. And if we check the pods, you see that the image tag is now 1.2. And the deployment desired state is also image with version 1.2. Now let's make one more change in our configuration repository to test that pruning the applications also works, which again means if I rename a resource, which means the resource with the old name doesn't exist anymore, or if I deleted this whole configuration file, then I want ArgoCD to also delete that component in the cluster. And let's test that. And I'm going to rename my deployment to just my app and commit the change. And again, after some interval, ArgoCD will sync those changes. And as you see, it removed the old deployment with my app deployment name, and it basically created a new one with its own replica set and started those 2 pods. So that means the pruning works as well. And finally, let's now try changing something in the cluster directly using kubectl command. So let's say I edit the deployment in my app namespace with the deployment name my app, and I want to configure 4 replicas instead. And I'm going to make my window a little smaller so we can see that in live. And as soon as I try to save these changes, you saw that 2 pods were added, but ArgoCD immediately reverted that back to 2 replicas because we have self-heal configured, which undoes any manual changes in the cluster. And if I do kubectl edit deployment again, you see that it again says 2 replicas here. So my change was basically reverted. And finally, if you're testing around with ArgoCD and you don't want to wait for the time interval to basically update your cluster, you can also trigger the synchronization with the Git repository manually. So first you basically refresh, which tells ArgoCD to compare the state in the cluster with the state in the repository, and then you can do sync, which will then actually synchronize those states. Now, if you learned a lot in this video, then please like it and share it with your colleagues so that they can learn about these concepts as well. And with that, thank you for watching and see you in the next video.